Today we're going to start section 1.2 using segments and congruence. A postulate is a rule that is accepted without proof. This means that we do not have to prove that these rules are true. It's just accepted. It's just known. The first postulate is the Ruler Postulate. The points on a line or a ruler can be matched one-to-one with real numbers. The real numbers that correspond to a point is the coordinate of that point. So in the example here, the coordinate of point A is 10. The coordinate of point B is 23. We know the distance between points A and B, or the length of AB, written as AB, is the absolute value of the difference of the coordinates of A and B. It is also called the length of segment AB. So to find the length of segment AB, we're going to find the difference between the 2 points. So the length of AB is equal to 23 minus 10. So the length of AB is equal to 13 units. It is important to note the notation. So the difference, if we write AB with the line segment notation above it, this is talking about the line segment. So we're naming the line segment. When we write AB without the line segment notation above it, we're talking about the length of the line segment. So with the notation, we're naming the line segment. Without the notation, we're talking about the length of the line segment. So a number. Pause the video and try the practice problem on your own. So to find the length of ST, again, we're just going to take the difference of the coordinates. So ST is equal to 17 minus 6, which is 11. So ST equals 11 units. We cannot have a negative value for the length of a line segment. So that's why the distance between the 2 points is the absolute value of the difference. So if you wanted to, you can also say ST is equal to 6 minus 17, which is equal to negative 11. But because we can't have a negative length, we want to take the absolute value of this difference. So again, we would get ST is equal to 11 units. When 3 points are collinear, remember collinear means they lie on the same line, you can say that one point is between the other two. So in this first example here, A, B, and C are collinear. They all lie on the same line. So we can say that point B is between points A and C. In the second example here, the 3 points are not collinear. Only point X and point Z are on the line. So here we cannot say that Y is between X and Z. Point Y is not between X and Z because all 3 points are not collinear. Our second postulate is the segment addition postulate. So if point B is between A and C, then we can say the length of AB plus the length of BC is equal to the length of AC. It's equal to this entire length here. So the length of AB plus the length of BC is equal to the length of AC. Also, if AB plus BC is equal to AC, then we can say that point B is between points A and C. So for example here, from NJ to Texas, we can say that is equal to the length from Texas to Kentucky plus the length of Kentucky to New Jersey. So we have from Texas to Kentucky is 1,000 miles. From Kentucky to New Jersey is 600 miles. So here we get a distance of 1,600 miles. Pause the video and try the practice problem on your own. So here we have to use the segment addition postulate to find the length of xz. So we have the length of xz here is equal to the length of xy plus the length of yz. So xz is equal to 23 plus 40. So xz is equal to 63 units. So for this next problem, we kind of have to work backwards, right? This time we're given the length of the entire segment, and we have to find the length of this smaller piece here, GH. So again, let's write out our segment addition postulate first. So we have the length of FH is equal to the length of FG plus the length of GH. So in this case, we were given the length of FH. We know that it's 36. We were given the length of FG, which is 21. And in this case, we're finding the length of GH. So here, instead of just adding, we're actually going to subtract, right? To solve for GH, we're going to subtract 21 from both sides. And we get GH is equal to 15 units. 36 minus 21 is 15 units. Next, we're going to talk about congruence. So line segments that have the same length, are called congruent segments. So congruent segments are segments that have the same length. A tick mark is used on each segment to show that they are congruent. So here there's a tick mark on AB, and there's a tick mark on segment CD, showing that AB is congruent to CD. So remember before I talked about notation, when we're talking about the length of a segment, we do not use the line segment notation above our letters. So length of AB is equal to the length of CD. Notice there's no line segment notation when we are talking about the length. To say that the segments are congruent, now we're talking about the segments, we're naming the line segments. We do have to use the line segment notation. So we have line segment AB is congruent to, so the congruent symbol is an equal sign with a squiggle above. So line segment AB is congruent to line segment CD. So notice the difference when we're talking about the lengths or the distance between the 2 points. we are not using the line segment notation. When we're talking about two segments being congruent, so specifically talking about the segments and naming the segments, we do use that line segment notation. So here we're going to try the practice problem together. We're going to plot the following points on the coordinate plane and label them by their letter. And then we're going to determine if segment JK is congruent to segment LM. So first, let's plot our points. For J, we have -3, so that's 3 to the left, and +4. So we have J. Next, we have K, 2 to the right, and 4 up. Next, we have L, 1 to the right, and 3 up. And then we have M, 1 to the right, and 2 down. So they want us to find the length of JK and the length of LM and see if these segments are congruent. So here, because we have a horizontal line, we can just count the distance or the length between the 2 points. So from J to K, we have 1, 2, 3, 4, 5 units. And for the length of LM, we have 1, 2, 3, 4, 5 units. Because the lengths are the same, we know the segments are congruent. So JK, the length of JK is equal to the length of LM, which tells us segment JK is congruent to segment LM.